So if you look at converging, so converging is light that comes in, and that light comes together to some point. Now the light that's really far away will go through the focal point. We'll get to that a little bit later. But it's just light that comes together. So when the light hits the surface of the object, whether it reflects or refracts, it's going to be brought together. Diverging is going to be spread apart. Notice that it still has this kind of focal point here, which we'll get to. But instead of the light actually going through the focal point, it just looks like it goes through the focal point. Okay, and so that makes the light spread out and go away from each other, which is called diverging. So diverging is when that light separates and goes away. Okay, so, and again, this works for reflection or refraction, right? Reflection is light bouncing off a surface, so that's what I drew here, light bouncing off the surface. Refraction would be if the light traveled through and then went through a focal point on that one as well. Okay? Lenses, we kind of talked briefly about. We said lenses would be the refraction of light, and that's how they make images. And then mirrors would be reflecting light, and that's how they make images. So lenses refract, and mirrors reflect. One thing worth mentioning, every single object reflects light, even lenses. Lenses, most of the light goes through. It's why they're called lenses. They do refraction. But every single object does reflection. If you don't believe me, look at one of the windows or look at the glass panels on the door. You'll be able to see things in them. Okay? And that's because they are reflecting some light. They're not just refracting the light. So it is a combination of both. All objects do this as well. That's how you know they're there. If there was no reflection, an object would just appear like a black void in space. Okay, and you don't see that. So there's always going to be some reflection of an object. Okay. Then we talked about the three parts of a mirror, but it also works for lenses. We said that principal axis is the imaginary line through which the midpoint of the lens travels. Okay, so here it is. Kind of imaginary middle point of the mirror. We said that the focal point is the location where parallel light is focused. Okay, so light comes in and goes through here. It's only for parallel light, so it's only for far away light. Assuming your eyes don't suck like mine. Okay? If you hold your hand in front of your face, no matter how far or how close, it's going to be focused on the back of your eye. And that's because when it's far enough away, that light is going to come in parallel to your eye, and therefore it's going to all reflect to the same spot, which is the focal point. However, it does not matter how good your eyes are. If you put your hand really close to your face, like not quite on your nose, but pretty close to your nose, there's no way you're going to see it clearly. It's impossible. Okay? And the reason is the light coming from there is not parallel. It's too close. Okay? So because it's not parallel, it won't get reflected exactly to the focal point, which means it's not going to be clear on the back of your eye. Okay, again, focal point is just for light that's really far away. For light that's not really far away, it'll reflect a little bit differently. Okay? All right, and then lastly, we talked about this last time, center of curvature concavity. It's the central point of a curved lens or mirror. It's always 2 times the focal point, no matter what. And then we get to the last 2 things, real images and virtual images. Real images appear to converge, real images actually converge at a location of the image, so the light actually goes to the place where you can see the object. And virtual images only appear to converge at that point. So this projection is a real image because it's actually going there. Like, I can see the light on my hand, right? It's actually reaching this point in space. It's not appearing to, it's actually getting there. If you stand and look at yourself in the mirror, it only looks like the light comes from there, okay? But it doesn't actually. But it is looking like it's coming from there, because if you step forward and look at yourself in the mirror, you get closer. If you step back and look at yourself in the mirror, you get further away. So the light actually looks like it's coming from there. It just isn't really. And the reason for that is your eyes are stupid. Okay? Your eyes are dumb. Your eyes can only see in a straight line. So if the air like bends or something like that, if it refracts, or it bounces off from a different source, like your eyes can't tell that. Your eyes only tell where the light comes from, and then they figure it out from there. A great example of this is mirages, right? So the light comes down, it refracts off the hot air, and then it comes up from the ground at you. So if you're looking at like a cloud, the light from the cloud comes in, bends up at you. So the light of the cloud actually looks like it's coming from the ground. So your eye's like, well, that makes sense. Clouds are in the ground. And so you see an image of the cloud on the ground. That's what mirages are. That's why it looks like water, because it's, one, the heat causes it to ripple, and two, you're looking at the blue sky. So you see the blue sky coming up from the ground, and your eye's like, oh, water in the desert. That makes total sense. And so that's how things, and that's also why optical illusions are so effective, because your eyes are dumb. They just can't figure it out. So just to kind of give you an idea of those. I'm going to show you one more example here real quick of a virtual image, or sorry, of a real image. Virtual images are super simple. They look like normal things in mirrors. But real images are sometimes a little complicated. So let me show you one more real image here, and then I'll pass it around so you can see. I'll do some virtual ones too. All right, I'm going to pass around two things. One for real, one for virtual, so you can actually see these a little bit. So I got two types of mirrors here. There's one on the back and one on the front. A virtual image is an image where you can actually see an object where it looks like it's coming from. So if you look on the back, you'll notice you'll see yourself inside the mirror, so that would be a virtual image. If you look on the front, you'll notice it's a little bit different. But experiment with how close or how far you hold it away. The closer or the further, the better. And you can kind of see a little bit of a change there with that one. So that'll help you with virtual images. And then this other guy is a real image. Okay. I got a coin inside of here. The way you do this one is you just hold it kind of in front of you, like a little bit down, but not right underneath you. So a little bit down, kind of in front of you, and look at what you see, and that'll be a real image. Again, the light is actually focusing in a real place in space. So you can see that. So I'll pass them around, look at them at your table, see what you can see with them, and then pass them on to the next table and just kind of snake them around. Okay, any questions on the definitions for these that you have questions on or need help with?